Hello everyone, this is Mr. West. Today we're going to be talking about systems of equations. So the first thing we need to understand is what is a system of equations. So we know the word equation, and that's an expression with an equal sign and terms on both sides. What about a system? A system is simply two or more equations. And generally for this section we're going to be specifically talking about two equations. So just two equations, but it has a potential for more than two. So what does it mean when we have a solution of a system? So if we're pairing two equations together, the solution is where the variables have, not are, have solutions that satisfy both equations. Okay? So normally if we have something as simple as x plus 3 equals 8, we know that x equals 5. Okay? So if we have two equations, we need to have the number that we find for x and y be true for both equations, okay? So we're going to see an example of what that looks like in just a moment. So our first example is, what is the solution to the system of equations? So here we have this orange line drawn, okay? And we can come up with the equation for this orange line fairly easily. So first we look at the y-intercept. So the y-intercept is 5, and we're going to put it into y equals mx plus b. Slope-intercept form, y equals the slope times x plus the y-intercept. Okay, so where is the y-intercept? We already said that is 5, so y equals, it's something plus 5. Now what is the slope? Well, we know it goes through this point, so that point is 1, 2, 3, 4, 5, that's negative 5. And it goes up 5 over 5. That's 5 over 5 slope, which reduces to 1. Okay, I'm going to erase that just a moment just to keep it clean, but I want you to see that that is the equation of the line. Okay, you do not need to do this just to understand what the visual representation of the solution is. I'm just telling you as a reminder, pardon me, how we would come up with the equations. Okay, so the next one, we have a green line here that's drawn. All right, so we need to start with the y-intercept. So the y-intercept is 5, so it's going to be something plus 5. And now we need to come up with the slope. So let's pick 2 points it goes through. This one is not as clear, especially because this is just hand-drawn. But we can come up with something, I think. Let's say that this point is on the line. So that would be the point 1, 2, 3, 4, 5, 6, 7, 7, comma 3. So it goes down 2 over 7. Down 2 would be negative 2 over 7. Put the x. There's our two equations. Okay. Again, for this particular problem, you do not need to understand what the equations are in order to solve them. But where do they have a solution? Where are the x and y values? Let me erase this just so you don't get confused. Where are the x and y values true for both equations? Well, it's already been kind of labeled for you. It is right here. That point satisfies both equations. And let me show you. So if we put, this point is labeled as 0, 5. Why does that work? Well, 0 is our x coordinate, 5 is our y coordinate. Now let's see what happens when we plug 0 in for x and 5 in for y into both equations. Let me start with this one. Okay, so already visually you can see that that's where they intersect. And that's something you can add here is the intersection. Okay, so the solution is also known as the intersection of the system of equations. Where you graph the two lines, that's the solution. Okay, so I am going to replace, I'm going to replace y also. I'm going to replace x and y in this equation. So I'm going to plug in 5 for y, 0 for x. 5 equals 1 times 0 is 0, plus 5 is 5. Is this a true statement? Yes. Okay, so that is true for the first equation. Okay, so 0, 5 is a point on the line. It is true for this equation. So we're good there. Now we need to test to see if it's also good for the green equation. So we need to plug in 5 for y, negative 2 over 7 times, we're going to plug in 0 for x, and also plus 5. All right, so let's plug in 5, 0. We get 5 equals negative 2 over 7 times 0 is 0, plus 5 is 5. Is that a true statement? Yes, it is. Because it is true for both equations, it is a solution to the system. Okay, so a solution to a system means that the x and y variables, the values that you have for the x and y variables, satisfy both equations. Okay, we're going to be moving on to a couple more examples after this video.